Okay, let's leave stoichiometry behind for a bit. Now, if that seemed rusty, you can go back to one of our handouts and work through some stoichiometry problems. But we're going to move on to significant figures. Now, with significant figures, we have a few different areas we need to work in. We need to be able to count them, we need to be able to calculate with them, and we also need to be able to do basic calculations. Now, we have three basic types of significant figures when it comes to zeros. While all non-zero numbers are going to be considered significant, our three types of zeros are going to render whether or not they're considered significant. We had trapped zeros, for example. For the number 1001, 1001, the zeros are trapped between two non-zero digits. Trapped zeros always count. Preceding zeros were our second type of zero. They come before the first non-zero number. They never count. They're basically placeholders. If you wrote a number in scientific notation, it would get rid of these preceding zeros as they're just there as placeholders. Now our third type of zero is a trailing zero. These are the tricky ones. Now if there's no decimal point, trailing zeros do not count, such as the number 230, 230. That zero does not count because there's no decimal place. But if we have a number 230.0, as there's a decimal place, both of those trailing zeros count. So we have four significant figures in the number 230.0. Let's get a little bit of practice in for counting significant figures. We have to be able to count our sig figs if we're going to do calculations with them. Starting on the left, 1201.2 has a trapped zero between the 2 and the 1, and all of the non-zero digits count, so we're going to put a little red box around all of the significant figures. We've got a total of 5 sig figs. Moving to the right, we have 100,100. In this number, we have trapped zeros, and we also have trailing zeros. Our trapped zeros count, and our trailing zeros don't count because there's no decimal place. So we're going to, again, circle the significant figures. We've got 4 present. Our third value only contains preceding zeros and non-zero digits. These preceding zeros we're going to disregard because preceding zeros never count. That leaves us with 3 significant figures. And our last digit here, we've got 0.10034. Again, trapped zeros are always going to count, but that preceding zero before the decimal place doesn't count, as preceding zeros never count. So we've got a total of 5 significant figures here. Now that we can count sig figs, we're going to move on to our first set of calculations. Now our first rule applies to addition and subtraction with significant figures. For addition and subtraction, we keep the fewest number of decimal places that we find in the numbers that we're working with. Now let's do a sample calculation of 2 minus 0.6. If we just type this into the calculator, we're going to get a value of 1.4. 2 has 0 decimal places. 0.6 has 1 decimal place. So when we get our answer, we should only have 0 decimal places in the answer, because we keep the fewest decimal places. So I'm going to draw a line in here on where we're going to cut off. So if we had a 5 or higher value instead of just a 4, we would have to round up to a value of 2 for our answer. But as the first digit that we discard is a 4, we're not going to round up, and our final answer is just going to be 1, which keeps 0 decimal places in our final answer. Now, multiplication and division is slightly different and subtly different. We're not worried about decimal places anymore. We're worried about total number of significant figures. We're going to keep the fewest number of sig figs that we find in the numbers that we're working with. In our sample calculation, we're multiplying 3.7 by 4.212. Typing it into the calculator, we get 15.5844. There are 2 sig figs in the first number that we're multiplying. and 4 sig figs in the second number that we're multiplying. So when we multiply them, our answer should only keep 2 significant figures. So we're going to cut off right before that 0.5. So the first digit that we would be discarding is 5 or higher, so we would need to round up 15 to 16, which is going to be our final answer, which contains 2 significant figures, which is the least number of sig figs that we used in our calculation. Our final topic today is conversions. This is a rough spot for many people. We've had a lot of practice this semester, but we want to make sure that we keep it fresh. Now, to set up a conversion, we need to memorize the metrics. If you have any weird conversions, such as English units or involving energy, you'll be given those conversions. But basic metric units, we need to be able to memorize the conversion factors for. One such sample problem is convert 25,677 millimeters to meters. We start out with what we're given, and then we work in a conversion factory that we've committed to memory. There are 1,000 millimeters for every 1 meter. We put the millimeters on the bottom so that they'll cancel out, leaving us with the unit of meters, which is where we want to end up. We divide 25,677 by 1,000, and that gives us a value of 25.677 meters, which is our final answer. Now let's keep moving. We're going to go through double conversions now. Double conversions involve the use of 2 separate conversion factors. Let's try out converting 25.6 pounds per minute to kilograms per second. We're going to start again with what we're given, but I'm going to write it a bit differently. 25.6 pounds / minutes is the same thing as writing 25.6 pounds over 1 minute, or per 1 minute. As we're starting there, we're going to take pounds to kilograms and minutes to seconds in 2 separate conversions. You would have to be given this conversion, but there are 0.454 kilograms for every pound. We put the pounds on the bottom so that they cancel out, leaving us with kilograms per minute. And now we need to take minutes to seconds as well. Now there are 60 seconds in a minute, and we're going to put minutes in the top so that our minutes are going to cancel out. Now the only units left that haven't been canceled are kilograms per second, and that's the unit that we want to end up with. Now as far as typing it into the calculator, we have 25.6 times 0.454 divided by 60, which gives us 0.194 kilograms per second for our final answer. I hope you guys enjoyed this review. We will see about putting them up for units 3 and 4 also, and thanks for coming.